Yeah. But first, come here, I want to show you something.
All right.
I want to see what you think about this. So I came across this the other day, and I wasn't sure what's going on, but I'm sure it's right. So if we have x equals a, all right? Now, they're both the same number, so we could add to both sides. So let's do this. We'll add a on both sides. All right? So now, this becomes 2a. Right? So now, let's subtract 2x from both sides. Right? Okay, that's reasonable. Okay. So now on this side, we got a minus x. And on this side, we got 2a minus x. So if we divide by a minus x on both sides, we get 1 equals 2. So 1 equals 2.
There's got to be something wrong. That's wrong. That saying 1 is equal to 2 is like saying the moon is made of cheese.
What? The moon is made of cheese.
What are you talking about?
Yeah. The moon's made of cheese.
Okay. Let's bring this up here. I want to see this. This is really interesting.
All right, I'll prove to you that the moon's made of cheese. So, the moon is made of cheese. So first, it looks like cheese, space cows, and a well-defined linking of the moon to cheese. So first off, it looks like cheese. For example, right there, dimples, we got craters. Looks just like cheese. And it could be from a space cow planet. According to well-known publicist Ian O'Neill, rampaging herds of fat space cows built the planets. It's an actual quote. So think about it. If there was a planet of space cows, what would they want with cheese? They won't want to eat the cheese, so they just end up leaving it here. So now linking the cheese to moon. So if you look at the moon set, it looks like an Oreo being dunked in milk if you reverse the colors. So, milk makes cheese. And cows produce milk, which is used to make cheese. Cows jump over the moon, so the moon is made of cheese.
Okay. Well, you have some good points there. That was really interesting. But I have a couple of issues I want to discuss with you. First of all, the appearance of physics. Now, I think they belong together because the appearance really owes itself to physics. And we also have mold and spoilage, naturally, of cheese, and melting. So the first thing I want to talk about is the appearance of physics. Okay, well, man has been to the moon, and we, of course, have pictures. So take a look over here. So from the pictures, you can see the moon's surface is a desolate, rocky, dusty place. At least it appears to be. So now, how does the moon stay up there? If it's made of cheese is lighter than rock, right? So wouldn't the moon have to be bigger to make up for the difference in mass?
Actually, I could prove why it's not. First, according to Fraser Cain, the composition of the moon is a bit of a mystery. So why can't those so-called dust particles actually be cheese particles? It could be grated Parmesan cheese for all we know. And still going off Fraser Cain's idea to disprove the physics that the composition of the moon is a mystery, the mass wouldn't come into account. If the density of the moon is unknown, it can't be proven that the current position of the moon isn't based off it being cheese.
Okay. That explains it. Okay, so what's my next thing? Mold and spoilage. Okay. I have a table here of cheese shelf lives from Dairy Goodness, which is a well-known dairy cooking site. And as we can see, cheese will last anywhere from a few days to maybe 1 year at most. So now, according to Xtalksnet, the safety of our food is a major concern to many people. So how safe is the moon cheese from spoiling anyway? We know that cheese we put in the refrigerator can spoil like that. Now who would eat that? Anyone want to eat that? I didn't think so. So what about that?
Okay, well, if you think about it, there's no atmosphere on the moon. And if we look at Mars from here on Earth, we can see that there's a haze due to the atmosphere on Mars. So that's how we can tell there's no atmosphere. The moon, it just looks like a big ball of cheese and there's no other clouds. Therefore, there's no atmosphere. And without an atmosphere, there cannot be mold on the moon because it won't grow without an atmosphere getting moisture from the atmosphere. So, another thing is, the average temperature on the moon is -9 degrees Celsius, so it's like having the cheese in your freezer frozen anyway. So it wouldn't spoil. What's that next?
Interesting. Okay. My next point is melting. Okay. Now I have a YouTube video I want to show you.
Hello, my name is Pete Dryden. Hello, my name is Pete Dryden, and I'm going to show you how to melt cheese in a microwave. You will need cheese, a plate, and a microwave. The first step is to take
You gotta minimize it. Minimize it.
Okay, minimize.
the cheese out of the fridge.
Really?
Hit the minimize
Then
button.
put
At
the
the
cheese
top.
on your plate.
Okay.
Then take the plate and put it in your microwave. There are a few different settings we can do here, but I want to melt the cheese completely, so we'll be cooking it a little longer. 30 to 35 seconds on high is a good way to melt the cheese completely. If you don't want to melt it completely, but just want to soften it, shoot for around 10 to 15 seconds. And that is how you melt cheese in a microwave.
Okay, so we've just seen that a microwave can melt cheese very effectively. Just about 30 seconds, you can have cheese completely melted. Now, Marshall Brain from How Stuff Works explains the function of the microwave oven. And he says the microwave oven uses microwaves to heat food. Now, from my physics and chemistry classes, I know microwaves are a form of electromagnetic radiation. Now, Science Daily defines solar radiation, energy from the sun. Solar radiation is radiant energy emitted by the sun, and it's particularly electromagnetic radiation. So, since electromagnetic radiation can melt the cheese, as we've just seen, why doesn't the cheese melt in the moon?
Alright, I got it. Here's the thing. It wouldn't melt. Restating the point that the average temperature on the moon's surface is -9 degrees Fahrenheit, so that's like having it in your freezer. So that's almost like having it frozen. Now, the temperature on the bright side of the moon can reach 212 degrees Fahrenheit, but the dark side reaches -223. So that, I think, would pretty much freeze it. So even if it does come to the close lit up side of the moon, it might melt, but the gravitational force will keep the melted cheese on the moon's surface until it reaches the far side of the moon and freeze again. And you could argue that it would boil off, but it wouldn't, because think about it, if you put a pizza in the oven and it's got cheese on it, you have it well over 212 degrees Fahrenheit, so you don't see your cheese boiling off your pizza, so it can't boil, so therefore there's no way that the moon would melt if it was cheese.
Okay.
So, now, I'm pretty sure I disproved all your points. I disproved the appearance, which could be from cheese, and the physics, which can't be proven against cheese because there's a chance that it is actually cheese because we don't know the density. And I disproved the idea of the moon being destroyed by mold and spoilage. And I gave an alternative idea to why the moon wouldn't melt.
Alright, that's it. There you have it. 1 is equal to 2, and the moon is made of cheese.